Today we will study reactions of benzene and methyl benzene. So it's an exam capsule and we will review it very quickly. So number first is the addition type of reaction, that we are starting with the addition of hydrogen. So when we have a reaction of a benzene with hydrogen, we would have a catalyst, a very famous catalyst, that is Rene nickel catalyst, that is used for hydrogenation. And when we have a reaction with the hydrogen, it would be addition reaction, and temperature required here would be around 140 degrees centigrade temperature is required to conduct this reaction. And then we would have a product. It's all double bond in the benzene ring will be broken, and we would have a cyclic structure. So no, it would have no ring inside the benzene will be lost. So it's cyclic, it becomes cyclo. And how many numbers it would have? 6 carbons, so it will be hex. And it has all single bond, so it would be hexane. So the product is cyclohexane. So after that we will study a very famous reaction of the benzene for which it is famous, that is ESR, that is called electrophilic substitution reaction. So number one, the first electrophilic substitution reaction is the nitration. So in the nitration process, we react it with HNO3. So when we have a reaction with HNO3, we have the catalyst. So I am writing catalyst over here. For nitration, it's H2SO4 will be the catalyst. Okay, when we have H2SO4 is the catalyst, what is going to happen? The hydrogen of the benzene will be lost, and then NO2 from the nitric acid will be attached, and it will be nitrobenzene along with the byproduct water. So it's a electrophilic substitution reaction. The second reaction is, you may say that halogenation. In halogenation, we know that it could be chlorination, bromination. So I am taking the example of just chlorination. It's Cl2. So when you are using Cl2, its catalyst will be FeCl3. Its catalyst will be FeCl3. So what would be the product? Chlorine will attach with the benzene by substituting the hydrogen. So it will be chlorobenzene along with the byproduct, that is HCl. Okay, the other one is we can have a reaction with bromine as well. So in case of bromination, that will also can be the electrophilic substitution if it would have the catalyst is FeBr3. So catalyst is important in explaining the concept of electrophilic substitution or selection. If you can judge by the catalyst. So I will explain it just after that, that how you can judge whether the reaction will be electrophilic substitution or not. So it's Fe bromobenzene plus HBr as a byproduct. Okay. So the next one would be, after that we can have a sulfonation. In this we react it with H2SO4. We react it with H2SO4. So what will be the product? It is benzene ring attaches with SO3H. So it's benzene sulfonic acid. That is also electrophilic substitution. And now we have a very important reaction on which the new reactions are based, that is alkylation. In the alkylation, we have the attachment of methyl group with the benzene. So we react it with the CH3Cl. We will react it with CH3Cl, and catalyst will be AlCl3. So what will be the product? It would be like methyl benzene along with the byproduct. It would be methyl benzene CH3 plus HCl. So now we will move on to the reaction of methyl benzene. Okay. when we have a reaction of methyl benzene with Cl2 in the presence of FeCl3 and hydrous. So what kind of product we would have? In the presence of FeCl3, it would have a substitution reaction, and we would have a substitution product like we were studying in the benzene. And methyl group is a 2,4 directing group. So if CH3 is there, then Cl will be on this point on the second carbon. It will be 2-chloro methyl benzene. And if we have a very important for the student, if we have the reaction of methyl benzene with chlorine in the presence of UV rays, so what kind of product we are getting? We would have substitution not from the benzene ring but from the alkyl group. It would be CH2Cl. And if we move for the further process, like it reacts further with the Cl2 in the presence of UV rays, so it would have again the substitution from the alkyl group or the methyl group outside the benzene ring reaction. It would be CHCl2. And then again, if its reaction will be with Cl2 in the presence of UV rays, the product would be CCl3. So tetrachloro, it will be 3 chlorine will be attached. So benzyl trichloride. And now, what will be the product of the oxidation? So always keep in mind, whenever a alkyl group, methyl, ethyl, propyl is attached with the benzene ring, we would have a one product. We would always have a one kind of product, that is CO2H. That is CO2H on the benzene ring. That's benzoic acid. Okay, so that was the reaction of main reaction of methyl. Even we can study the nitration. What we will do for the nitration? It would have a reaction with HNO3, and this reaction will be more quicker and more faster than the reaction of benzene ring. So that's for the sure. When any substituent is attached with the benzene ring, its reaction will be quicker. So here no H2SO4 will be catalyst. When the methyl benzene is reacting with the HNO3, that's called the nitration of methyl benzene, and we would have a substitution, and NO2 will be attached on the second carbon, not on the third carbon. It can be attached on second or fourth because methyl group is 2,4 directing group. That was the quick review from reaction of benzene and methyl benzene. Thanks.